Hi dear children, welcome to today's class. Today we are going to discuss exercise 7.10, that is integration by using substitution. Okay. So the first question, integral 0 to 1 x divided by x square plus 1 dx. Integral 0 to 1 x divided by x square plus 1 dx. In this, we are going to put t equal to x square plus 1. Okay, this problem you can do it in two ways. Either first you can find out that indefinite integral corresponding to this. After that you can give x is equal to 1 and x is equal to 0. Or you can directly evaluate this definite integral. Okay, you can directly evaluate this definite integral that I am going to do here. T is equal to x square plus 1, then dt is equal to 2x, dt by dx is equal to 2x, and dt is by 2 equal to x into dx. We will get dt by 2 equal to x into dx. Okay, this is substitution. In the case of definite integral, we need to find out the range. Okay, we need to find out the range of that new variable also. Okay, that is the additional step in the case of definite integral instead of indefinite integral. Okay, indefinite integral we will give some substitution. After that we will convert our integrand completely into that new variable, right? So in the case of definite integral, one more extra step is that we need to find out the that interval of a new variable. We need to find out the interval of a new variable. For that, first x is equal to 0. If x is equal to 0, the value of t is 0 square plus 1. Just put x is equal to 0 in that substitution, then we will get t is equal to 0 plus 1, that is t is equal to 1. And if x is equal to 1, then t equal to 1 square plus 1, it is equal to 2. So the new interval is 1 to 2. The new interval is 1 to 2. Now this integral become integral 1 to 2, not 0 to 1, it is 1 to 2. Integral 1 to 2 x dx, that is dt by 2 divided by t, and this is equal to 1 by 2 into integral 1 to 2 dt by t. And what is this integral dt by t? That we know, that is log mod t, right? That is log mod t, that we know. But here the t varies from 1 to 2, and in the interval 1 to 2 that t is positive, so we can avoid this modulus symbol. It is from 1 to 2. And this is 1 by 2 into, now we need to substitute t equal to 2 minus t is equal to 1. And we know that log 1 is 0. So thus we will get it as 1 by 2 log 2. So the answer for this question is 1 by 2 log 2. Second question. Integral 0 to pi by 2. Integral 0 to pi by 2. Square root of sine phi cos raised to phi d phi. Okay, instead of that x, here we have phi. So I'm going to make one adjustment here. Integral 0 to pi by 2 root sine phi. This cos raised to phi we can write it as cos raised to 4 pi into cos phi into d phi. And this is equal to integral 0 to pi by 2 root sine phi. And thus we can write it as cos square phi all square into cos phi d phi. And this is equal to integral 0 to pi by 2 root sine phi cos square phi, that we know, that is 1 minus sine square phi all square into cos phi into d phi. Now we are going to give substitution, that is, this is our I now integral. Now we are going to give substitution, that is, let t equal to sine phi. T equal to sine phi, then dt by d phi is equal to cos phi, and dt is equal to cos phi d phi. dt is equal to cos phi t phi. Now we need to find out the interval of this no variable t. For that, when phi is equal to 0, t equal to sine 0 equal to 0. When phi is equal to pi by 2, then t equal to sine pi by 2 equal to 1. So the new interval of integration is from 0 to 1. So then I is equal to integral 0 to 1 root t 1 minus t square all square cos phi into d phi, that is our dt, and this is equal to integral 0 to 1 root t, that is t raised to 1 by 2, and 1 minus t square all square, that we can expand it by using a minus b all square. So 1 minus 2t square plus 2t raised plus t raised to 4 into dt we will get. Now we are going to open that bracket. I is equal to integral 0 to 1 t raised to 1 by 2 minus 2 into t raised to 1 by 2 into t square plus t raised to 1 by 2 into t raised to 4 dt. Okay, and this is equal to integral 0 to 1 t raised to 1 by 2 minus 2t raised to 5 by 2 plus t raised to 9 by 2 into dt. Now we are going to integrate it. The integral of t raised to 1 by 2, that is t raised to 1 by 2 plus 1 divided by 1 by 2 plus 1, that is t raised to 3 by 2 divided by 3 by 2 minus 2 into t raised to, the 5 by 2 integral is 5 by 2 plus 1 divided by 5 by 2 plus 1, right? So that we will get it as 5 by 2 plus 1 is 7 by 2 divided by 7 by 2, and 9 by 2 plus 1, this is 11 by 2. So t raised to 11 by 2 divided by 11 by 2 from 0 to 1. Now this is equal to, now we are going to substitute the upper limit and the lower limit. 2 by 3 into, if you substitute 1 raised to 3 by 2 is 1 itself, minus 4 by 7 into 1 plus 2 by 11 we will get, and if you put 0, that entire term becomes 0, and after this calculation you will get it as 64 divided by 231. 64 divided by 231. Now third question. Third question, integral 0 to 1 sine inverse of 2x divided by 1 plus x square dx. Integral 0 to 1 sine inverse of 2x divided by 1 plus x square dx. And here we are going to put x is equal to tan t. X is equal to tan t. Then dx by dt is equal to 6 square t, and dx is equal to 6 square t into dt we will get. And now if x is equal to 0, then if x is equal to tan t, then t equal to tan inverse x, right? If x is equal to tan t, then t equal to tan inverse x. Now if x is equal to 0, this implies t is equal to tan inverse 0, and that is equal to 0. And if x is equal to 1, that implies t is equal to tan inverse 1, that is equal to, tan inverse 1 is pi by 4. Okay, now we will give this substitution in our integral, that is integral, no interval of integration is 0 to pi by 4. 0 to pi by 4 sine inverse of 2 tan t divided by 1 plus tan square t dx, that is 6 square t into dt. 6 square t dt, and this is equal to 2 tan t divided by 1 plus tan square t. 2 tan t divided by 1 plus tan square t, that is sine 2t. So we are going to apply that here. This is equal to integral 0 to pi by 4 sine inverse of sine 2t into 6 square t dt. And this is equal to sine inverse of sine, the 2 tan t divided by 1 plus tan square t. 2 tan t divided by, this is pi by 4. 2 tan t divided by 1 plus tan square t, that is our sine 2t. Sine inverse and sine get cancelled and we will have integral 0 to pi by 4 2t 6 square t dt. And thus 2 is constant, we can take it outside. Then 2 into integral 0 to pi by 4 t 6 square t dt. T 6 square t dt we will have. Now we are going to integrate it. Here we have the product of two functions. We have the product of two functions. So we need to use integration by parts. In this question. So what comes first here? Algebra comes first here. Okay, here algebra comes first here. So in that technique, algebra and trigonometric function, algebra comes first here. Okay, so we will take t is equal to u and this 6 square t is equal to v. So by using integration by parts, that 2 is constant in u into integral v dt minus integral d by dt of u into integral v dt into dt, and we need to give the that values 0 to pi by 4. So after all the integration only we will substitute t equal to 0 and t equal to pi by 4. So after all the integration we need to give it from 0 to pi by 4. Now this is equal to 2 into t into integral 6 square t, that we know, that is tan t, minus integral d by dt of t, that is 1, and the integral 6 square t, that is tan t dt from 0 to pi by 4. Okay, thus values we will substitute after all the integrations. So 2 into t tan t minus this integral tan t dt, that is log mod sec t from 0 to pi by 4. So t tan t minus log mod sec t from 0 to pi by 4. Now we are going to substitute the values because all the integrations is over here. So we need to substitute the value. First we will substitute the upper limit, that is pi by 4 tan pi by 4, that we know 1, minus log sec pi by 4 minus of 0 into tan 0. 0 into tan 0, that we know, that is 0, minus log mod sec 0. Okay. Pi by 4 into 1, that is pi by 4 itself. So this is equal to 2 into pi by 4 minus, what is sec pi by 4? Sec pi by 4, that is root 2. Okay, sec pi by 4, that is root 2. So we will have log root 2. Root 2 is positive, so no need to take the modulus. Sec pi by 4 is root 2. Minus 0, minus minus become plus. So plus log sec 0. Sec 0, that is 1 by cos 0. Cos 0 we know, that is 1. So sec 0 is 1. So we will have log 1 This is equal to 2 into pi by 4 minus log root 2. Log 1 is 0. Okay, so the answer we will get it as pi by 2 minus 2 log root 2. Pi by 2 minus 2 log root 2. Okay, that is our answer. Now we are going to do the fourth question. Fourth one, integral 0 to 2 x into root x plus 2 dx. And here we are going to put t equal to x plus 2. Then dt by dx, dt is equal to dx we will get. dt equal to dx we will get. And when x is equal to 0, t equal to 0 plus 2 equal to 2. When x is equal to 2, t equal to 2 plus 2 is equal to 4. So the new interval of integration is 2 to 4. Then this integral become integral 2 to 4 x, integral 2 to 4. Here we have x, thus t is x plus 2, then x is equal to t minus 2. So t minus 2 into root t and dx is dt. So the new integral is integral 2 to 4 root t into t minus 2 dt. Now this root t we can write it as 2 to 4 root t is t raised to 1 by 2 into t minus 2 dt. And now just open that brackets, then we will get t raised to 1 by 2 into t raised to 1, that is t raised to 3 by 2. Okay, t raised to 3 by 2 minus 2t raised to 1 by 2 into dt. Now we are going to integrate it. So t raised to 3 by 2, if you integrate that, we will get t raised to 5 by 2 divided by 5 by 2 minus 2 into t raised to 3 by 2 divided by 3 by 2 from 2 to 4. From 2 to 4. And this is equal to that is equal to 2 by 5 t raised to 5 by 2 minus 4 by 3 t raised to 3 by 2 from 2 to 4. Now this is equal to 2 by 5 4 raised to 5 by 2 minus 4 by 3 4 raised to 3 by 2 minus 2 by 5 2 raised to 5 by 2 minus 4 by 3 2 raised to 3 by 2. If you substitute the upper limit and lower limit, we will get like this. And what is this 4 raised to 5 by 2? Okay, this 4 raised to 5 by 2, we will get it as 4 raised to 1 by 2 is 2. 2 by 5. 4 raised to 5 by 2 we can split it as 4 raised to 5 by 2 we can split it as 4 raised to 1 by 2 all raised to 5. And 4 raised to 1 by 2, the square root of 4 that we know, that is 2. And this is 2 raised to 5. And 2 raised to 5 is 32. Okay, we will get 2 raised to 5, that is 32. Okay, so this is 32. And this 2 raised to 5 by 2. Okay, 2 raised to 5 by 2, that is actually 32. Okay, thus we can write it as 2 raised to 5 by 2. We can write it as 2 raised to 5 all raised to 1 by 2. 2 raised to 5 by 2 we can write it as 2 raised to 5 all raised to 1 by 2, right? So that is 2 raised to 5 is 32 all raised to 1 by 2. That is square root 32. Thus we can write it as square root 16 into 2. That is equal to 4 root 2. Square root 16 into 2, that is equal to 4 root 2. I am going to take that two terms together because 2 by 5 is common, minus 4 root 2. Okay. Now the remaining terms, minus 4 by 3. Okay, minus 4 by 3. I am going to take it common. Then 4 raised to 3 by 2 we have 4 raised to 3 by 2, that is 4 raised to 3 by 2. We can write it as 4 raised to 1 by 2 all cube. And this is equal to 2 cube. 2 cube is 8. So we will get 8. And minus minus become plus. And I took one negative outside. So I will have minus here. So minus 2 raised to 3 by 2. That we can write it as 2 cube all raised to 1 by 2. That is 8 raised to 1 by 2. Square root 8. We can write it as square root 4 into 2. So this is 2 root 2. Square root 8 we can write it as square root 4 into 2. That is 2 root 2. So minus 2 root 2. Now after all the calculations, you will get it as 16 root 2 divided by 15 into root 2 plus 1. 16 root 2 divided by 15 into root 2 plus 1. Now fifth question. Integral 0 to pi by 2 sin x divided by 1 plus cos square x dx. Sin x divided by 1 plus cos square x dx. In this t is equal to cos x. Then dt by dx is equal to minus sin x. That is minus dt is equal to sin x into dx. And if x is equal to 0, t is equal to cos 0 is equal to 1. If x is equal to pi by 2, t is equal to cos pi by 2 is equal to 0. So this new interval of integration is from integral 1 to 0. Integral 1 to 0 minus dt divided by 1 plus t square. Minus dt divided by 1 plus t square. And this is equal to, we know that integral dt divided by 1 plus t square, that is of the form integral dx divided by 1 plus x square, that is tan inverse x. So we will get minus tan inverse t from 1 to 0. So that is minus tan inverse 0 minus tan inverse 1. That is equal to tan inverse 0 is 0, minus minus become plus, and tan inverse 1 is pi by 4. So the final answer is pi by 4. Now question number 7. Integral minus 1 to 1 dx divided by x square plus 2x plus 5. Okay, just look at the denominator. If you want to integrate that type of integrand, we need to apply completing the square method first. So that I am going to do first. Integral minus 1 to 1 dx divided by x square plus 2x plus half of the coefficient of x, that is 1. So we need to add 1 square and subtract 1 square. And this is equal to integral minus 1 to 1 dx divided by the first 3 terms x 1, and here we have plus symbol, so x plus 1 all square, minus 1 plus 5, that is plus 4. Now this is of the form integral. Okay, we need to that is of the form integral dx divided by x square plus x square, but instead of x we have x plus 1. So we are going to put t is equal to x plus 1. Then we will get dt equal to dx. And when x is equal to minus 1, we will get t equal to 0. And if x is equal to 1, we will get t equal to 2. So this new integral is from 0 to 2, and dx, that is dt, divided by t square plus 2 square. T square plus 2 square. And that is of the form integral dx divided by x square plus a square, that we know, that is 1 by a tan inverse x by a. So this is 1 by 2 tan inverse t by 2 from 0 to 2. Tan inverse t by 2 from 0 to 2. Now just substitute t is equal to 2 first. 1 by 2 we can keep outside. T equal to 2, we will have tan inverse 2 by 2 is 1 minus tan inverse, if you substitute 0, 0 by 2 is 0. And this is 1 by 2 into pi by 4, because tan inverse 0 is 0. 1 by 2 into pi by 4, that is equal to pi by 8. We will get the answer, that is pi by 8. Now 8th question. 8th question. Integral 1 to 2 1 by x minus 1 by 2x square e raised to 2x dx. Integral 1 to 2 1 by x minus 1 by 2x square e raised to 2x dx. In this I am going to put t equal to 2x, then dt is equal to, if t equal to 2x, then we will get x is equal to t by 2, and dt is equal to 2 into dx. dt is equal to 2 into dx we will get, or dx is equal to dt by 2. Now if x is equal to 1, then t is equal to, if x is equal to 1, then t is equal to 2, and if x is equal to 2, then t equal to 4. So the new interval of integration is from 2 to 4, and this integral become, let it be I is equal to integral 2 to 4 1 by x is t by 2 minus 1 by 2 into t by 2 all square into e raised to 2x, that is e raised to t, and dx is dt by 2.